All right, y'all, we're looking at the 1-10 notes, talking about absolute value function attributes. Okay, so we start off on this front page with the exact same graph that we looked at in 1-9. Okay, it's the parent function. It's the simplest possible version of an absolute value function, where y equals the absolute value of x. There's nothing else added or subtracted. There's no coefficients. There's no negative signs anywhere. It's just absolute value of x, and that's all. Okay, so I got this list of y values exactly the same way I did in the previous lesson. Okay, what I did was I just take that x value and I substitute it in to this function right here. Okay, the absolute value of -3, well, that's +3, so that's our y value. Same thing going all the way down, absolute value -2, absolute value -1. We did the same thing going all the way down. Okay, and what that does for us is it creates a graph that's this V shape right here, okay? And you can see our y values start up high, they go down, and when they get to this place, they turn around and start going back up. That's what gives us this V-shaped graph, okay? Just like we talked about the other day, the domain on an absolute value is always infinities because we've always got arrows on both ends. The range on this particular one, that's not always going to be the same, but on this one, it bottoms out down here at 0. And both arrows pointing up means it goes up to infinity. The x-intercept is 0 and the y-intercept is 0. Both of them are that same point down here at the bottom that we were just talking about. Okay, that was the vertex point. And actually, that definition is on your next page, the axis of symmetry and the vertex point. That turns out to be some very interesting and important information right there as we move along through this, okay? So what we're going to do today, is just a very simple continuation of the same idea as what we were doing before, okay? All we're going to do is we're going to plug in some x values, see what we get as y values, and then compare our new graph to that original parent function graph, all right? So when I plug in -3 into this equation, I'm substituting -3 wherever I see x, so it becomes the absolute value of -3 plus 2. Well, the absolute value of -3 is +3. So this whole thing becomes 3 plus 2, which is 5. Now I do the same thing, going down the list. I plug in -2 right here. The absolute value of -2 is +2. So this whole thing becomes 2 plus 2, which is 4. Okay, if I replace that and go -1, it becomes 1 plus 2, which is 3. 0 plus 2. Then I start getting into positive numbers. Well, if I replace that -1, make it +1, the absolute value of 1 is 1. So it's just 1 plus 2 again. And then it's 2 plus 2. And then it's 3 plus 2. Sorry about that mistake there. Okay, so I want you to look at this list of y values and compare it to the y values from the parent function. Do y'all see the relationship that we have there? We started off with y values that are up high, they drop down, and then they get to a place where they turn back around and start going up. We have the exact same relationship in these y values. Okay, so what I'm going to do is I'm going to plot these points. -3, 5, 2, 4, 1, 3, and so on. Okay, I'm going to plot these points and draw the graph the same way that I did on the last one. Okay, plot those points, draw that line that connects them all, make sure you've got arrows on the end so it's looking good. Okay, so we can see by this that our domain is the same. Okay, the domain is always the same infinite domain for an absolute value function. But the range this time has changed because there's a different place that we bottom out. Okay, the bottom end of our range is now at 2 instead of 0. In fact, you can see that the whole entire thing, not just that one point down there, the whole entire graph compared to our original parent function, that graph compared to this one, the whole thing has shifted up by 2 units. Okay, that's what we're going to list right here. The whole thing has shifted up by 2 units. We'll talk more about that in the next lesson, all right? Our x-intercepts, we don't have any. so I'll put none. Our y-intercepts, we've got one at 2. The axis of symmetry, like we talked about in the last lesson, is a vertical line that cuts the thing in half. Okay, that line right there. And the vertex is the point on this graph that has the line of symmetry going through it. It'd be this point right down here, okay, that corner point. So the vertex has coordinates, okay, and I'm going to show y'all the relationship between the axis of symmetry and the vertex. The vertex down here is at the coordinates of 0, 2. Just like we said in the last video, whatever the x-coordinate is right here, that's what your axis of symmetry is going to be. X equals 0. Okay, that 0 and this 0 came from the same place. Okay, they are always going to be the same. Wherever the vertex is, that x value is your axis of symmetry. And the last thing, this vertex, obviously, since it's at the bottom of the function, is a minimum. Go on to our next one. I actually don't want to use the list of numbers that is printed on there. I want to use these x values, -6, -5, -4, -3, -2, -1, up to 0. And we're going to do just like we did before. We're going to plug in these x values, substitute them in right here, and evaluate the function. All right, so we've got absolute value of -6 plus 4. Well, -6 plus 4 is 2. The absolute value of 2 is 2. On the next one, we plug in -5, and it becomes -5 plus 4. Okay, -5 plus 4 is -1. The absolute value of -1 is 1. When we plug in -4 right here, -4 plus 4 is 0. Absolute value is 0. Up next, we've got -3. -3 plus 4 is 1. The absolute value is 1. -2 plus 4 is 2. Absolute value of 2. -1, you're going to see the pattern going right here, right? Let's go ahead and plot these points. -6, 2. -5, 1. -4, 0. And then it turns around and starts going back up, right? -3, 1. -2, 2. It starts going back up like this. Okay, so let's graph that function, connect all of those dots, get the whole function graphed. Your domain is the same as before. Nothing has changed about that. The range going from bottom to top, well, our lowest y value, the lowest y value in this range is 0. It goes up to infinity. X-intercepts. We've got 1 right down here. It's at -4. We've got one y-intercept up at +4. Our axis of symmetry and the vertex are related to each other. So if there's the axis of symmetry, the vertex is going to be this point right down here. The coordinates of that point, -4, 0. And so we see that -4, and we know that that's going to be our axis of symmetry also, x equals -4. Since this is down at the bottom of the function, that vertex is a minimum. Okay? So when we look at this graph, compare it to our original. Okay, our original had the vertex right there in the center. This whole thing has been shifted to the left by 4 units. Again, we're going to talk more about that in our next lesson, all right? So there we have it. All of our transformations listed, domain, range. Okay, your homework problems are going to be very, very similar to everything that we just saw on the notes, okay? There's a couple extra questions that if you're not sure, you need to ask me about, all right? Just let me know as you're working through it. Send me an email. Come by to tutorials, whatever you need to do, all right? That's all we've got for the notes today. Y'all have a good one.